what do we do first? The parentheses. So that would be 9 minus 7 plus 2. Bring everything else down. You guys are not wanting to show all your steps. What's next? 2 times 3 would be 6. Again, bring everything else down. Now all that's left is addition and subtraction, so we'll work left to right. 5 plus 6 is 11, minus 12 is negative 1. Okay, now we are moving into equations. I'm super excited. So if you look at our objective, it says we can solve one-step equations. Okay, now academic has already been doing one-step equations, but there's a difference. They spent a whole day on adding and subtracting, and then they spent a whole day on multiplication and division. We are doing all 4 one day. Tomorrow, at the end of class, we have an exit ticket. It's a half of a minor on just one-step equations. Very good? Okay, so that means, that's what I'm trying to say, you need to hone in, focus, ask questions if you don't understand, okay? We have an expression versus an equation, all right? An expression is made of numbers and operations. It may have a variable. Expressions is where we've been so far, for the last week and a half or so, just in expressions. So like 5 plus 7 plus negative 3. That's an expression. Or algebraic might be 5 plus x plus negative 3, where we replace one of our letters, one of our numbers with a letter. The top one we can solve, right? Because we're just combining numbers together. But the second one, can we solve that? And no, and that's what we talk about. You can't go any further with this. I mean, you could combine, I guess, the 5 and the negative 3. But you can't then go any further because you don't know what x is and you don't know what it's equivalent to. Okay? Versus an equation is hang on. It's a mathematical sentence with 2 equivalent expressions. So there are expressions inside of an equation. Okay? A numerical example might be like 5 plus 7 equals 6 plus 6. What do you now see that you didn't see before? The equal sign. Okay, because 5 plus 7 is equal to 12 and 6 plus 6 is equal to 12. Algebraically, you might see like 5 plus x equals 12. Okay? So tell me, what does an expression and an equation, how are they similar? What do they have in common? Both have, well, not just minus, what would you say? Operations. And what do they both have? Numbers. And they both might have variables. Okay? But how are they different? There's one huge thing. Just tell me. Equal sign. An equation has the equal sign. And in the word equation, that beginning, that beginning, that's a clue that there's an equal sign. That's what makes an equation. And so now we can actually start solving. Okay. Just like we started with expressions, we're starting with the model. Yes, we will move away from the models, but the model is a good place to start because you can see why the math is the way it is. All right? So I have 3 different kinds of models right here. X plus 3 equals 5. What do you think this first picture is? What is that?
A scale.
It's a scale. Like, where have you seen one of those? In science, like it's a balance scale, right? And how do balance scales work? You put stuff on both sides until what? Until they're balanced out, which means that they're equal. Okay, right? They're not tippy. Okay. Okay, so in this case, if I were to put an imaginary line there between my two halves, on the left-hand side just has x plus 3. On the right-hand side is just 5. I know right now if I ask you what's the value of x, everybody in here can tell me that. That's not what this is about. This is about modeling and showing, okay? This next one is a bar model. We've used bar models in the past. The top bar is equivalent to the bottom bar. So what's going to go on the bottom? 5, because that's our pole, right? What's going to go on the top? The x and the 3. This means x plus 3 is equivalent to 5. You have seen something like this in elementary school. You called it a part whole picture. Part whole. It's the same thing, okay? And the last one is just a map where we're going to show algebra tiles. So x plus 3 equals 5. Just showing you with algebra tiles. Okay? Okay, and now we want to represent this with a word problem. So we might say something like, Miss Ballish had some candy. Okay, do we know how much candy? No. So what is that representing in our story? X. Okay. Then Mr. C gave her 3 more pieces. And she had 5. So then what would the question be for this example? How many? What's the unknown? Right, how many pieces did you start with? Okay. There's an infinite number of examples we could do here. I just thought that one was easy. Okay. Okay, let's look at the next one. 2x equals 8 can be modeled various ways. Same thing, we're going to imaginary line, our scale, 2x and 8 are equal to each other. All right. On the bar model, what is our whole? 8. What's going to go up here? Yeah. Guys, if you said 2 and x, that would be 2 plus x. That's not it. It's 2x, which means 2 x's. Okay? X and x. Okay? And then we have our algebra tiles. So 2x equals 8. All right? And then a story problem, let's not write it. I'm just looking at our time. You could have said something like, Miss Ballish had 2 boxes of markers, which totaled 8 markers. What would the question be? How many markers are in each box? That's right. Okay? Are we good so far? Excellent. All right. The best thing about equations is that you can solve them. There is a solution, okay? When you replace a variable with a value that results in a true sentence, you solve the equation. That's why a lot of y'all have not been very satisfied with expressions because there was no solution. Thank you. There was no solution to that, right? So there was just simplifying it, and that was it. Okay? So the value for the variable is the solution of the equation because it makes the equation true. So, in this example, 2 plus x equals 10. 2 plus what equals 10? 8. And then therefore 10 equals 10. Therefore, those 3 dots, remember that means therefore, the solution to the equation is x equals 8. Guys, please do not just put 8. The solution is x equals 8. Okay? Let's go to the next one. 18 equals 6x. So you should be thinking 6 times 3 equals 18, because 18 equals 18. Therefore, the solution solution to the equation is x equals 3. Okay? All right. Down here, sometimes you're going to get one that looks like this. Determine if the given value makes the equation true. So what they're saying is, I'm giving you 3 choices. Figure out which one of those makes it true. You're going to do that by simply filling it in. 7 plus 3 equals 10. See, I just plugged in 3 for A. Is that true? Yes. 7 plus 13 equals 10. Is that true? No. So I'm going to put a mark through my equal sign. What does that mean? It means not equal. Okay. And so then 7 plus 17 equals 10. Is that true? No. So we mark it out. Okay. So based on this, we can say, therefore, A equals what? 3. That is the value of A that makes it true. That's all you do. Okay, look at the next one. Here are our possible solutions. 14 minus 9 equals 3. Is that true? No. 14 minus 10 equals 3. Is that true? No. 14 minus 11 equals 3. Is that true?
Yes.
Yes. Therefore, M equals not 3, 11. Remember, it was where you put the M. It was where you put the M. Okay? All right, guys. Questions so far? But these are my notes. Remember, we always do more on our notes. I always look back on it and figure out what happened. Okay, now, you guys, there's this you try section. We're going to come back to this unless you think we absolutely need it right now. Okay, just going based on the day, I'm going to go ahead. Okay. Now, in the interest of time, braining camp is what we're going to use, but I'm just going to model it for you guys, okay? And instead of us doing it, okay? So, if you were on braining camp, you would go to Algebra Tile, and the first question is, what is it, x plus 4 equals 10. All right, so guys, what you would want to do is divide your screen in half. Okay, so you're looking, you're not writing anything, you're just watching. Okay, and we're going to model this with the algebra tile. So you would put x plus 4 equals 10, right? This is where my clicker,
I'll be your clicker.
well, it won't let me click, just click. Oh, look at it. Oh, I did it once. Spoke too soon. Oh, okay, that's interesting. Okay, so now, okay, here's the thing. Let me just back up for just a second. When it comes to solving equations, okay, I know right now you all know the value of x. Okay, that's not what this is about. This is about showing mathematically why this works, so that when the numbers are more like 44,855 and this number is 10.3, you'll know how to do it. Okay? Okay. So the whole point of equations is to solve for x, right? I'm trying to get what just this one x is equal to. So that means I need to get rid of these guys, right? But I can't just take them and throw them away. That's not how this works. But I can make their value non-existent. How can I get rid of 4 positives? If I subtract 4, if I bring in 4 negatives, do you guys see how now this side of the equation has value of just x? Okay. Picture the balance scale. A second ago, it was like this, right? But now when I brought in these 4 extra negatives, what's happening? It's like tippy, right? Okay? So I can't, it's not equivalent. What do I need to do? There's the rule. What you do to one side, you have to do to the other side. So if I brought in 4 negatives on the left, I need to bring in 4 negatives on the right. Now, I can show 0 pairs, like we did earlier in the week, okay? And I have 0 pairs over here, okay? And so now, do I have just x by itself? Yes. And what's it equivalent to? 6. It's equivalent to 6, which again, I think you already knew, but this is just showing you why the math works. Are you with me? Okay, so now let's go back to our paper, and now we're going to model it. If you have a more than one color, that might be helpful. Okay, so first, we're going to divide our scale and draw x plus 4, but now you're going to record it on your paper. You didn't record anything, because I told you just to watch. Okay? I did that in one color. Now I'm going to pick up a different color, just so that you can see the original numbers versus what you are doing. You told me to isolate the variable, which is the fancy way to say get x by itself. You're going to bring in 4 negatives, right? Okay, and what you did to one side, you had to do to the other, and then you had 0 pairs over here as well, and now you were left with just x equals 6. So see, that's how you draw out what we just did in writing again, okay? Now, models are great. They have their purpose. It's so that you can see why we do what we do. But let's face it, where we're really going to be living is algebraically. That means without drawing a model, what do we do? And when you, wait, and my friends right now, those of you that like to do it all in your head, please trust me. Okay, when I tell you to show these steps, because when these numbers are easy peasy and cheesy like they are right now, this is so easy. But soon, like tomorrow, the numbers are going to become much more difficult, and you're going to need a good strategy. Okay? So, I'm trying to get x by itself, right? What's happening with x right now? We're adding 4. So, to get rid of something, I want to do the opposite, or the inverse. So, that would be to do what? Subtract 4. But what's the rule? What you do to one side, you got to do to the other. So I'm going to come over here. And so then positive and negative 4 zero it out. And all I was left with is x. 10 minus 4 is what? 2. And that's it. The final step right here, it says you should always check your work to know immediately whether your solution is correct. So meaning write down the original problem, but instead of x, put a 6. And then ask yourself if that's true. Is 6 plus 4 equal to 10? Yes. Yes. So that's how we know we did it right. Okay? Let's do another. This time we're not going to do it on grading camp. We're just going to draw the model. Okay? So x minus 3. So what do I need? An x and then 3 negatives. Equals 6. Okay? There's my original problem. I'm trying to get x by itself, so I have to get rid of 3 negatives. What do I need to bring in? 3 positives, because I know that those are going to zero out. What you do to one side, you do to the other. If I have any 0 pairs, I'm going to mark it out. I do not have any on the right this time. No big deal. What's left on the left? Just x. What's on the right? 9. 9. And that's it. Okay? Algebraically, isn't it satisfying? Yeah, I agree. Algebraically, x minus 3 equals 6. Okay, what's happening with x and the number? It's being subtracted. What is the inverse? Adding. So I'm going to add 3 to both sides. These zeroed out, and we're left with 6 plus 3, which is 9. You got it. Plug it back in. Is 9 minus 3 equal to 6? Yes. Yep. What if it didn't? What if it didn't work? Like, what if you put 8? 8 minus 3 is 5, not 6. So what would you need to do? You need to go back. That's somewhere you made an error. Okay? All right, guys. If you will flip to the next page, just 1 and 2. So you try on the addition and subtraction. Here are some positive. Okay. Go ahead and check. So she would have got x equals 9 for the first one and x equals 1 on the second one. Any questions, you guys? Yes, sir.
How do you know when you're there on the right side?
Well, because it's when you have positives and negatives. So like on this one, on the right side, I only have positives, so I can't make zero pairs. Here, I ended up with positives and negatives, and every time you have a negative and a positive, that equals 0. Yeah. Anything else, you guys? How are we doing? Okay, go back to the previous page, and now we're going to move on to multiplication and division. All right? Okay, so number 3, if you go back to the previous page where it says 4x equals 8. Okay? Divide our scale. What would that look like? 4 x's. And what? 8 on the right side. Okay? So, what are we always trying to do again?
Leave x alone.
Get 1x, right? 1x by itself. We'll find the value of 1x. So in this case, I'm not going to be taking anything away. I just need to find, I've got 8 things and 4 x's to put them on. So how many are going to end up on each one? 2. Yeah, you're just going to put 2. 2 on each x. So no zero pairs or anything. You're just dividing the original 8 by the 4 places to put it. And so x equals how much? 2. Okay? Algebraically, what is happening with 4 and x right now? It's being multiplied. So the inverse would be to divide. Guys, when we show division, I just draw a line like that. Divide by 4. What you do to one side, you do to the other, just like we did before. Because 4 over 4, what does that equal? 1. What? 1. Right? 4 over 4 is 1 whole. And then, so then I could put 1x here, or I could just put x. Because we know when we put x, that means 1x. And then 8 divided by 4 is what? 2. Plug it back in. Well, this makes sense. 4 times 2 is 8. Okay? And then division. Number 4 says 1/2 x equals 6. Now, right now it doesn't look like division. Can I rewrite this so that it looks like division? How would you write that? Yeah, x over 2 equals 6. That's the same thing as 1/2 x. Okay? Now, in our model, how am I going to show half of x? Or x divided by 2? What do you want to do? Okay, so draw an x, but then I only need half of it. Half of that x is equivalent to 6. Well, if the top half is equal to 6, what's the bottom half? Yeah, this bottom half would also be 6. So now do I have 1 whole x? And what's it equal to? Right, it's equal to all of these, which is 12. Okay, so let's go through that one more time. When it was a fraction, I cut it in half in this case. And if I said, well, if the top half was equal to 6, then the bottom half was also equal to 6. So then that means 1 whole would equal all of these. Okay? Okay, let's write it down algebraically. Okay, what is happening with x and 2 right now? It's being divided. So the inverse would be to what? Multiply. So I would multiply by 2, again, both sides. Now, before I go on, it's not a mistake that I put that 2 up in the air. Why? Right. It's really because it's 2 over 1. So there's 2 ways that you can do this. 1 would be to go 2 times x, which is 2x. 1 times 2 is 2. And now you've created your 1 because 2 over 2 is 1, right? Or look back at here. Think way, way back. Cross simplifying, that's right. 2 goes into 2 once, 2 goes into 2 once, and then look, see? There's your x. Okay? So either way you want to do it, just like we always say, it doesn't matter. And then 6 times 2 is 1. Plug it back in. And it was true. Some people think that the multiplication and division is actually easier than the addition and subtraction. I tend to agree because there's not zero pairs. Yes, yes.
Can you explain the equation?
This?
When you're showing the words out,
Yes.
I didn't get that.
That's fine. I'm going to do it again. So that's a this. Let me do it again. Okay? So if we're saying x over 2 equals 6, right? So we said the opposite of division is multiplication. So that means you would multiply both sides by 2, right? So really this is 2 over 1. So if you cross simplify, those both become 1 and you're just left with x. Or if you didn't, then that would have been 2x over 2 and there's your 1. It's the same thing.
Oh, okay, no, I got that. I got
Okay?
that.
Okay.
Yeah.
Okay, so guys, now back on that next page where we were a minute ago, go ahead and do the bottom two. Number 3 and 4 on your own. Okay, check your answers. You should have got x equals 3 on the first one and x equals 20 on the second one. Any questions?
No.
Can I go over anything?
Yes, I don't get the bottom part.
On which one?
The
The bottom one. So we were saying that half of x is equal to 10. Well, half by definition means exactly in the middle, right? Like a butterfly, like if this half matches this half, right? It has to match. So if the top half was 10, then that means the bottom half also has to be 10. So then when I'm trying to solve for a whole x, which is all of it, that means I need all of them.
Okay, yeah, but I get that part. I don't get why x over 2 is half.
Because maybe x over 2 is the same as 1 half x. Is that what you're asking?
Yeah, that's
Can anybody help? I'm not sure why, like how to help her. Caitlin, why? Well, x is not equal to 1, but it's 1x. It's 1x. Does that help? Now do you see the 1 half?
Oh, wait, okay, yeah, now I did.
Think a long time ago, when we did the scale factor, remember when we said that the scale factor, if we said the scale factor was 2, then that meant you were multiplying by 2, and I said if you divide by 2, then that meant it was 1 half. Remember that?
Yeah, no, I get it now. I thought x equals to 1.
Oh, no. Okay, thank you for clarifying that. Okay, now, guys, let's look at this one. Word problem. It says Ruben and Tarek have 245.5 downloaded minutes of music. If Ruben has 132, how many belong to Tarek? Write and solve an addition equation to determine how many minutes belong to Tarek and what property did you use. So if I were you, I would write Ruben plus Tarek equals 245.5. Oh, do we think we're going to use a model on this one?
Yeah.
No. Why not? Decimals and I'm going to draw 245 circles. Okay, so, guys, Ruben was 132, so I'm going to replace R with 132. Okay, so here is my addition equation. So I've solved half of the problem. I've gotten half of my points right now. This was on your quiz Friday. Okay, now I would, how do I solve?
132 minus.
In order to get rid of 132, I would need to subtract it from both sides. all I would be left with is T over there. And I get 113.5 minutes. Okay, so, earlier in the day, someone asked the question, well, couldn't we just have subtracted in the beginning, you knew it was subtraction? No, because it specified that it wanted that addition equation, you would have only gotten half credit, okay? If this had just been asking the question, how many minutes were taught, okay? Okay, guys, the next page, that is your homework.